Okay, now in this video, I'm going to show you some of the other WAN technologies which can be used in today's networks. That is MPLS, multi-protocol label switching. Now, this is one of the most popular WAN technology which is used in today's networks. Now, the main reason is it's more like a frame relay only. It's just works like a frame relay where you have a pre-existing service provider network, and we call this as MPLS core. Typically, we call as MPLS core the backbone of the service provider network, which is built by the service provider. And then let's take an example. I got a customer A, and the customer A wants to provide connectivity to customer A on the other side. Now we are going to connect to the nearest service provider device. And in case of MPLS terminology, we call this as provider edge routers. Provider edge routers. Provider edge routers, and the middle routers we call them as provider routers. And the customer routers we call them as customer edge routers. Now the major difference between the frame relay and this one is when you're sending the packet, it will go as a normal IP packet. But when it enters the service provider, the packet is forwarded from this end to this end, other end of the customer, in the form of a label rather than forwarding based on the normal IP packets. And that's what we call as label switching here. Now, multi-protocol label switching, we call this as multi-protocol label switching. Now, the reason for that is multi-protocol means this technology can be implemented on any kind of layer 2 connection. Now, the connection which is built between the routers, whatever the connection we are using between customer to service provider or between service providers, it can be any form of layer 2 connection. Like it can be a serial interface running a PPP HDLC encapsulations, or it can be an Ethernet interface like we discussed in the Metro Ethernet lines. It can be your frame relay, or it can be your lease line. It can be any kind of layer 2 connectivity. So that's the reason we call as multi-protocol. It might be using any encapsulation, any layer 2 protocol, and all the packets are switched based on the labels rather than forwarding based on the IP packets or any other formats. Now, this is something most of the service providers has been using nowadays, and it's one of the common topic in the service provider as well. Now, the major reason is it's more scalable. So that is one of the major advantage most of the service providers uses when you compare with frame relay or lease line connections. It's a little bit scalable for the service provider networks because it's something like, the service provider is going to build once a core network and is going to sell for many customers. So let's take an example here. You have a service provider network. This is a core network, and right now currently we have somewhere around 100 customers. Let's say we have some 100 customers, and the service provider is providing the 100 customer sites. In fact, we can say around 20-30 customers, probably 100 sites. Now, in the next couple of months, probably the customer might increase their own locations, or you may have some new customers. Probably it changes to 200. Now, without making much changes or without actually upgrading much, we can still provide the connectivity for these 200 customers as well. Now, the good thing about this MPLS is once you build, you can add any number of customers. Just you connect to the nearest possible service provider device, and then you can build one logical virtual private network we call as logical VPN tunnel, which can be built, which allows you to send traffic from one end to another end in the form of a label rather than forwarding based on the packets, rather than based on the IP packets. Okay, so the service provider is going to build one time, and it's going to provide it's going to use all the possible routes. Like there is something called multi MPLS traffic engineering concept in this. It's something really very advanced topics where it is going to see if the customer requirement is, let's say, 2 Mbps of traffic, and if this particular link is not having 2 Mbps of bandwidth, in that case it can redirect from alternate possible route and then to reach the other end of the destination. So it uses all the possible routes, and whichever the route is having that 2 Mbps of bandwidth, it is going to use that particular route. And the forwarding is not based on the routing, not based on the routing best route. It's based on some conditions we can define the minimum bandwidth required, and based on that conditions, it is going to use all the possible routes. Now, apart from that, The actual traffic, let's say there is something called 192.168.1 network, which is customer A LAN interface, trying to communicate with 192.168.2 network on the other side. Now, once the customer traffic enters, there is a logical virtual connection which is built by the service provider from this end to that end. Now, we call this as MPLS VPN. Now, once the customer traffic enters, it's not going to forward based on the customer source and destinations. It's going to add one label. Now, you have a normal packet here. It's going to add one label here. And the customer traffic is forwarded based on the label by seeing this label, not seeing the actual IP header. And it will forward it on the remote destination, remote VPN, remote P router based on the label, and then it is forwarded back again to the customer as a normal IP packet. So when the customer is sending as a normal IP packet, receiving as a normal IP packet, but in between the packets are switched based on the labels rather than forwarded based on the IP addressing. Now, one of the major benefit here is without knowing the actual customer routes, the service provider will be still able to forward the packet. That's one of the major reason here, without knowing the actual IP header, because normally what happens when any packet is sent to the next router, if that router don't know the destination network ID in the routing table, it will drop the packet. But here it's not seeing that packet, it's seeing the label which is assigned by this router, and it will remove on the next router. So this makes a little bit scalable for the service provider, because the service provider no need to maintain the customer routes in each and every routing tables. And it also gives the flexibility that you can have some other customer also using the same network, no problem, because this customer is using one network, this customer also might be using one network, but still it's not going to create any problem, because the actual forwarding is based on the VPN label, that is MPLS label, not based on the actual IP header. Now there are some more advantages, like there is a concept of virtual route forwarding here. In fact, there are many things in this MPLS. We are not getting into all those things. I'm just highlighting some of the few important points here. It supports something called virtual route forwarding, where a router can have multiple routing tables on the same router. So it's more like, let's take an example. I have a customer router. Let me take an example. I have a customer A, customer B, customer C. They are based on the same location, and they are connecting to the same service provider. Probably my service provider is a service provider 1, and they are connecting to the router. Probably they might be connecting to the same router through some LAN, but there is a possibility that the routes coming from the customer A can leak into customer B and customer C. Now, to prevent that, we need to do some route filtering kind of things, like where you can do some ACL, where you need to say that any routes coming from here should not go to here. It's going to make much complications. So instead, or there is one alternate solution. What service provider can do is he can say that, okay, we got 3 customers, and all the 3 customers will be connecting to 3 different routers. So that is one more thing. But now, in this case, we are not going to do that. The service provider provides a router. The router can have multiple routing tables and multiple VRF instances. Now it means that this router is going to maintain a separate routing table for VRF A, that is what for customer A, and a separate routing table for customer B, separate routing table for customer C. Now you have a concept of virtual route forwarding, a concept where you can have a single router can have multiple routing tables without, it's like separate router only. And also it has one more routing table, that is global routing table, which is used inside the service provider network. And any routes coming from this customer A will be automatically placed in a separate routing table based on the configurations. Again, we have to apply this interface under the VRF, something like that. Any routes coming on this interface will be automatically placed in the separate routing table, and each and every routing table is isolated with each other by default. Now this is also one more flexibility which will be provided in the MPLS, where you can have multiple customers connecting on the same provider edge router, but still differentiate by using some different VRFs. And then when it goes through the service provider network, they add some labels, and each and every traffic is forwarded based on the labels, which is going to simplify the job of the service provider. So that makes MPLS a little bit more common technology which is used in service provider network when it comes to modern kind of WAN connections, uh, modern kind of WAN connections. If you talk about service providers, or if you're doing some any CCNA, CCNP service provider tracks, so most of the concepts will be covered more in detail on MPLS technologies.